MS Ramaya University of Applied Sciences.
Hi viewers, let's discuss on conductometric estimation. Conductometric titrations are based on Ohm's law. There are three types of conductance: equivalent, molar and specific conductance. In this experiment, with the help of titration, we are measuring specific conductance of the solution. The SI unit of specification conductance is S bar M. We can use the specific conductance data during the acid-base titration to estimate the amount of the acid in a given solution. Before doing the experiment, let's understand where all conductometric titrations are advantageous over volumetric and potentiometric titrations. Mixture of acids can be titrated more accurately by conductometric titration. Conductometric titrations may be applied where potentiometric titrations fail. Gives accurate reading in dilute solution as well as in concentrated solution. It can be employed for colored solutions. Aqueous solutions of very weak acids cannot be titrated potentiometrically, but then they can be titrated conductometrically with relative ease. HCl is a strong electrolyte and dissociates completely. Before the addition of NaOH, specific conductance of HCl is maximum due to highly mobile H ions. After the addition of NaOH, highly mobile H ions are replaced by less mobile Na ions, which results in reduction of specific conductance. Specific conductance decreases steeply till all available H ions react with the added NaOH. Further addition of NaOH would add more Na ions and OH ions. Due to relatively higher mobility of OH ions, specific conductance of solution increases again. Procedure: pipette out 25 ml of HCl into a clean beaker. Dip conductivity cell in the acid. Connect the cell to conductivity bridge. Measure the specific conductance before the addition of NaOH. Take the given NaOH in burette. Note the specific conductance of solution each time after adding 0.5 ml of NaOH and mixing. In the beginning, specific conductance decreases and increases after neutralization point. Take 8 to 10 readings afterwards. Plot a graph of specific conductance versus volume of NaOH added. Determine the volume of NaOH required to neutralize HCl. From the given normality of NaOH, calculate the normality and concentration of HCl. Precautions to be taken during experimentation. Temperature during the experiment should be kept constant as conductance depends on temperature. Adequate stirring should be done after each addition of titrant to ensure uniform mixing.
Hi students, aim of the experiment is to find out the amount of HCl using a standard NaOH conductometrically, means using its conductance, one of the property of a acid, like electrolyte. I can say it as an electrolyte. So all electrolytes will be having the ease of movement, means if it is a strong electrolyte, movement of the ions will be very fast. So weak electrolyte, movement of ions will be less. So using this property of this solution, we are going to find out its concentration. By knowing its concentration, we are able to find out its amount of a given strong acid to you. Conductance of the solutions will be depending upon its mobility of the ions, charge of the ions and concentration. So here, if you are varying the concentration of the ions, then its conductance will also be varying. Using this property, we have designed this experiment to find out the percentage of given acid using a strong NaOH using conductometry as an instrument. The apparatus used for this experiment is conductivity. So this is conductivity meter, where we have a knob for temperature adjustment. This is to mode whether you are adjusting the temperature or you are measuring the conductance, and this is the range in which the conductance is present, means it is present in millisiemens or in microsiemens. This is depending upon the concentration of the solutions. So we should not touch any of this because this will be adjusted by us, this is calibrated depending upon the concentration of the given acid. So you have to just see whether this knob is in the conductance or at the temperature. Strong acid. So this is a strong acid which you have to determine the amount of acid, given acid inside the solution. So a strong acid written as strong acid for conductivity. A strong base. To measure the conductivity of a strong acid, you are using this strong base whose you can say it as a standard base whose normality is known. conductivity cell. So this is conductivity cell whose cell constant is 1 plus or minus with 10% of error, and it consists of 2 electrodes, and the 2 electrodes both are platinum electrodes. So one will be behaving as an anode, another will be behaving as a cathode. 2 platinum electrodes which are platinized to increase its conductance, and this cell is connected towards the conductometer. The pipette, this is 25 ml pipette, which we are going to use it for the measurement of given strong acid for the experiment. The burette, this is burette where we are going to fill the standard NaOH solution, and a beaker, clean and dried beaker to carry out the experiment. Along with this, we are using an wash bottle to wash the apparatus which we are going to carry out the reactions. So these are the required apparatus to perform this experiment. Now let us start the experiment. Before starting the experiment, see that all the glass apparatus have been cleaned and used. So this is a microburette, so you have to wash with the distilled water. So wash with distilled water first, add enough quantity of distilled water and remove it from both the ends down and also from the upside. So and a cleaned conical flask you have to use. To rinse with the standard sodium hydroxide. Add some small quantity, and rinse it so that water is completely removed. So that care should be taken that you are not diluting the standard sodium hydroxide solution. So now it is rinsed, the sodium hydroxide solution. You have to fill it up with the standard sodium hydroxide. And the care should be taken that there is no airdrop in the burette. Adjust it to the 0 mark, the lower meniscus, since it is a transparent solution, the lower meniscus should touch the 0 mark. So now it is 0. So your standard solution is filled in the burette. So standard solution is ready. Now you have to wash your pipette. So you are using 25 cm cube of your pipette, 25 cm cube pipette. Take some quantity of water in the beaker, suck it, to the bulb, thoroughly wash it up to the mark, and then throw the solution. When you are using the distilled water, you can do it from both the sides. So using this pipette, I want to take 25 cm cube of strong acid. To take the 25 cm cube of strong acid, we have to use a cleaned beaker. The beaker should be cleaned. So first you have to rinse the pipette with the strong acid, that what we are going to find out the concentration. So you have to rinse. Rinse means you have to take little bit quantity of the strong acid, and then rinse it. So this process is called as rinsing, where we are taking little bit quantity and then seeing that water in the pipette has been completely removed. The pipette is rinsed. So now you have to take 25 cm cube. So a known volume of strong acid, you are going to pipette it out to the cleaned beaker. So cleaned beaker you are going to use. To that you are going to transfer it. So above the mark, then adjust the lower meniscus should be touching the mark. So 25 cm cube. So now transfer it to the beaker. So complete 25 cm cube should be transferred to the beaker. So touch the nib towards the side of the beaker. So now it is done. The complete transfer has been done. So now we have to wash the conductivity cell. Carefully remove it out. Wash it. The platinum electrodes should be washed. So you have to pour the water from this hole. So to pour the water from that hole, so it will be going and washing the electrodes. So on both the sides, the walls, small hole is there to see that the electrodes are washed thoroughly. Now remove the water. Remove the water and then keep it inside the solution. That means the solution that what you are going to find out the concentration. So you are using the strong acid. So dip it inside the strong acid and arrange it. So one care you should take here, you should see that both the platinum electrodes are kept or dipped inside the solution that what you are going to measure. So why? Because you are going to measure the specific conductance here. Specific conductance you are going to measure. That's why we are using this. You have to see that both the electrodes are kept inside the solutions. So now we are going to start the experiment. So start the experiment by on the conductometer. So for 25 cm cube of your solution of your strong acid, some conductance is already there. So 32, it is showing as 32. Note down the reading for 0 volume of NaOH, 32. Then go on adding 0.5 cm cube. So 0.5 cm cube, slowly add drop wise. So this is 0.5 cm cube. So each 1 cm cube as divided into 10. The middle one, the bigger one is 0.5. So 0.5 cm cube I have added. So now we have to see that the reaction is complete here. We can see there is a change in conductance. The conductance is going on decreasing. So each 0.5 cm cube, note down what is the change in conductance. So it is going on decreasing. Why? Because we are decreasing the concentration of a given strong acid. Strong acid, H ions. H ions concentration is going on decreasing, so the conductance is also going on decreasing here. .5 cm cube. Each addition you have to blow so that the reaction is complete inside the beaker. Continue the titration till we can see that there is a decrease in conductance. So go on continue the titration till what point? Till what point? There should be increase in the conductance. So it is decreasing from 30, it has decreased to 13 now. So each 0.5 addition, so what is the change in conductance you have to be noting down. So now also it is decreased from 13 to 11. So next 0.5 ml addition once again. So 13 to 10. So it is remaining same. So usually it should increase. Now you can see there is an increase in the conductivity. So you have to go on adding, still the conductance is going on decreasing, and then when it starts to increase, you have to continue the titration for 4 more readings and then stop the experiment. So in between those two, there lies the equivalence point. So this finish of the experiment.
At MSR UAS, we spark your imagination unlike any other.